So now we'll be talking about fenestration, which is basically windows and doors and skylights, if you want to include those. Windows, glazed doors, dynamic glazing, skylights, and window film have a significant impact on energy use in a home. They may account for up to 50% of residential space heating loads, and for homes that are air conditioned, up to 50% of the cooling load. The size, orientation, and types of fenestration products can dramatically affect the overall energy performance of the house. So there's different types of fenestration products which we'll mention. It's manufactured products, side build products, and field fabricated products. The manufactured products are the windows that you're going to see 90% of the times in residential construction. So they're delivered pre-assembled from the factory. And like I said, this is the most common type of fenestration in residential construction. They come in a variety of frame types. The most common you're going to see is vinyl, but they also have fiberglass. They also have wood. Older ones that you'll see in existing homes, perhaps, you'll see aluminum. So there's a variety of them. They can be single pane, dual pane. There's a wide range of types that you can see of this particular product. We then have side build products. They're glazed or assembled on site using factory prepared systems. They're more common in non-residential construction and include storefronts and curtain wall systems. The glazing contractor may also pre-assemble side build fenestration at his or her shop before the final installation. So again, not very common in residential construction. You might see them in some custom homes type scenarios, but for the most part, it's going to be a non-residential application. And again, these are basically windows that are built by a manufacturer, but they come in pieces and then they're built on site. Now, field fabricated products, they're built on site using standard dimensional lumber or other materials not intentionally prepared for use as a fenestration product. You're not going to see this a lot in production homes. You might see them in custom homes and so forth, but nonetheless, it's a product that's out there. So there's labeling requirements for windows as well. So standard windows require to have both a temporary and permanent label that shows the NFRC performance values. So on the left-hand side, you'll see the temporary label, and on the right-hand side, you'll see the permanent label. So manufactured windows are required to have these labels. The manufactured windows are the windows that I told you are the most common type of window used in residential construction. So we'll talk about these labels here in a sec, but nonetheless, the temporary label is on the window when it comes off the trucks, and then it gets removed at final cleaning or final inspection, or whatever you want to call it. And then the permanent label should be affixed on the frame of the window for the lifetime of the window. So that's always going to be there. And generally speaking, you're going to find it on the interior of the frame, somewhere on the slider and so forth. So like I said, both labels are required for manufactured products. Both labels are required for side build products, but a label certificate can replace the temporary label. Now, that's only specific for side build products. Keep that in mind. The manufactured products have to have those labels. Like I said, temporary labels should not be removed until after the inspection by the enforcement agency. And then labels are not required for field fabricated products. And this is an example of what the temporary label looks like. And those are the values associated with these labels. Now, one thing I want to point out is that as a HERS rater, you are not required to verify window values unless you're specifically contracted to do so by the builder or maybe the installer, or maybe you're taking part of some kind of above code program that requires you to do this. But window values are not, I repeat, they are not a HERS measure. But nonetheless, they are a Title 24 requirement. So the UFactor measures the rate of heat loss through a product. So the lower the UFactor, the lower the amount of heat loss. So basically, it's the insulating property of that particular window. So when you have a window in a wall, you basically have a very big hole in your insulation or your thermal boundary that we talked about earlier, right? So the UFactor measures how well that particular glass pane can stop heat from being lost. Heat loss, exactly. So the lower, the more efficient. Now, the solar heat gain coefficient measures the rate of heat gain from solar energy passing through a product. The lower the solar heat gain coefficient, the less amount of solar heat gain. So basically, how well is that window going to stop solar radiation from coming into the house? And again, the lower, the more efficient it is. Visible transmittance measures the amount of light that comes through a product. So the higher the VT rating, the more light is allowed through a window or a door. You can think of this as the tint of the window. And then you have air leakage. It's the amount of uncontrolled air movement through the casing of a window. So the higher the rating, the more air leakage exists. The prescribed standard is less than 0.03 CFMs per square foot of window surface area. That's just the standard. But basically, all windows leak at a minimum, just because of the fact that there is seams, there is moving parts. Therefore, there is no way to make a window 100% airtight. So the air leakage is a portion of the window value, and there is a standard minimum that it should meet. Now, as far as the UFactor that we talked about, there are mandatory requirements when it comes to those values. So the maximum UFactor for all climate zones in the state is 0.58. And again, we're saying maximum because the lower the better. So it cannot go above 0.58.
And we also have prescriptive requirements. These are going to be based on the climate zone in which you're building. So for climate zones 1, 3, 5, and 16, you have a maximum UFactor of 0.30 and you don't have a maximum solar heat gain coefficient. You can be whatever value you want. Those climate zones are generally the colder climate zones here in California, so a little bit of additional heating through the windows is not a bad thing, so we don't put a minimum or a maximum on that. Now when we look at climate zones 2, 4, and 6 through 15, those are more cooling climates. So not only do we have a maximum UFactor of 0.30, we also have a maximum solar heat gain coefficient of 0.23. There's also some limitations on the maximum fenestration area. So 20% of the conditioned floor area can be glass, and then on the west facing side, there's either no requirement or 5%, depending on which climate zone you're in.
So for exterior doors, any door that is more than 1/2 glass is considered a glazed door. It must comply with the mandatory and prescriptive measures and other standard requirements that apply. Doors with less than 50% glass area, up to 3 square feet, are exempt from UFactor and solar gain coefficient requirements. And the doors also must meet the same air leakage rates as the windows, which, like I said earlier, 0.3 CFM per square foot of door area. Now, there are things that we can talk about when it comes to improved window performance, and these are not items that are in Title 24, but nonetheless, these are things that can help installers or builders add certain products to increase the values of their windows. So dynamic glazing products are either internal shading systems or electrochromatic devices and are considered a fenestration product. Internal shading systems include blinds positioned between glass panes that can open and close. The labels for internal shading systems will reflect the endpoints of the product performance for UFactor and solar gain coefficient ratings only. And this is an example of dynamic glazing. You can see you have the window frame and you have the shading system built within the panes themselves. That's a perfect example of dynamic glazing. And then as you can see on the labels, for UFactor and solar gain coefficient, there is a range of values, whether the shading is open or closed. So those are going to be variable values. Now, chromatic glazing type fenestration have the ability to change its performance properties. The occupant can control manually or automatically their environment by tinting or darkening a window with the flip of a switch. Some windows and doors can change the performance automatically in response to a control or environmental signal, sometimes referred to as smart windows. So this is an example of chromatic glazing window. So the best example that I can give you that's really easy to think about, it's like those sunglasses that change tint whether you're inside or outside. So it's glass that can adjust automatically to environmental factors, or like the previous slide said, it can be done through a flip of a switch from the user. And as you can see here is the same window that's changing tint depending on different scenarios. And again, the label on the right hand side, the values are still variable depending whether the tint is on or off. In addition to it though, you also have the visible transmittance being variable, because now the tint of the window is also changing. So therefore that value is also going to be variable. Now for window film, there are three basic categories. You have clear, dyed, or vacuum coated. Now for window film is actually allowed to be taken for Title 24 compliance, and it's mainly used in additions and alteration type scenarios. When new windows are being installed, for the most part, the windows that are coming straight from the manufacturer already are going to be tinted. They already are going to have window films built on them. So window film, you're not going to see that in new construction, but nonetheless, window film is allowed to be used for Title 24 compliance. And again, it's mainly used for additions and alterations. So clear window film are used as safety films and to also reduce ultraviolet light fading damaging rays. They're not used for solar control or energy savings. You have dyed films that reduce both heat and light transmission, mostly through increased absorbance. And they can be used in applications where glare control is desired. Now, vacuum-coated films can be metallized or sputtered. They're reflective films that are preferred. They are the preferred film in most energy savings. They reduce transmission through reflectance, and they are manufactured to selectively reflect heat more than visible light through various combinations of metals. So the vacuum-coated films are the films that are a lot of times or mainly put on by manufacturers on the windows themselves before they ship. So they're actually part of the manufacturing process. And this is an example of a window film label might look like. Now in regards to windows, we talked about ways to improve the efficiency of the windows. We also got to talk about shading devices. So shading devices are an additional way to increase the efficiency of the window itself without actually modifying the window. So we have fixed permanent shading, exterior shading, and interior shading. So fixed permanent shading actually offers compliance credit. So fixed permanent shading is actually modeled in the CF1R. And the examples of them are side fins or overhangs. So these are shading devices that are part of the building design. And again, it could be an overhang, a cantilever, a vertical fin. Any of these are an example of fixed permanent shading. For example, a second story cantilever that extends over the first story as a porch, and it's shading the bottom windows. That's an example of fixed permanent shading, and that actually gives credit for Title 24 if modeled properly. Now exterior shading, these are exterior shading devices. It offers compliance credit, but the devices have to be permanently attached to the structure. And this is just an example of what some of those shading devices might be and the solar regain coefficient value that might add to the window. And again, keep in mind, shading devices only increase the solar regain coefficient because they're minimizing solar heat radiation from coming into the house. They're not going to increase the UFactor. It doesn't provide any additional insulating property to the window. Now interior shading, so now we're talking about blinds, shutters, whatever it may be. It doesn't offer compliance credit. It's still effective in reducing heat gains. However, like I said, it doesn't count for Title 24. The CEC considers interior shades in the category of home furnishing and not a feature of the house that is provided by the builder. And because for the most part interior shading can always be moved, removed, changed, and so forth, it's not really a permanent fixture. Therefore, it doesn't give Title 24 compliance. Now, in addition to the items that we talked about, you also have advanced window design. So depending on how the window is designed with the most modern technologies and so forth, the values of the windows for efficiency-wise are going to be much better. So when we're thinking about the values, when we're talking about solar regain coefficient and UFactor, all these items play a part into those particular values. So the frame material and configuration. So basically, is the material fiberglass? Is it vinyl? Is it aluminum? Is it wood? The material will affect the efficiency of the window. The configuration as well. Is it a fixed window? Is it a slider? Is it a single hung? Is it a porch door? Whatever it may be. The number of panes of glazing. So is it single pane, dual pane, triple pane? The number of panes will affect the U-factor of the window. The gap width between the panes. That's very important. The spacer materials. So basically the spacer that keep the panes separated. It's those rods that keep the single, dual, triple pane separated from one another. If that material is solid metal, it's going to be much more conductive than, for example, a hollow fiberglass rod. That's going to make a difference. And also the fill gases. So a lot of times manufacturers put fill gases between the panes to increase the U factor of the window. Carbon dioxide, argon, krypton, those are different gases that are in there. Obviously the gas will dissipate over time, but nonetheless it will have its highest effect when the window's new. But nonetheless, those gases do make a difference. So whether the window has a gas or not, or whether a window has a different type of gas in it, will definitely increase or decrease the U factor of that window. So let us know if you have any questions via the messaging system, or shoot us an email or give us a call. There was definitely a lot of information covered in this PowerPoint, and this is new material to you. I would be surprised if there was no questions. So feel free to reach out to us or save your questions for the field training, so you'll be able to ask the questions to your field trainer.